Hey everybody, this is Mr. Mazzoro, and today I have one of my favorite lectures to give. It's the asteroid that killed the dinosaurs. And I want to actually talk a lot about that asteroid and really what it is, partially because a lot of people misunderstand it. A lot of people just glaze over it. Oh, this asteroid killed the dinosaurs, but they really don't understand the ramifications of that statement. Really what happened, because if you take a look, everything was going pretty much gangbusters, and then all of a sudden, not only do you have a massive decline in angiosperms, but you also have a massive decline at this time in gymnosperms, and a massive decline in seed in spore plants. Everything goes down. It's the largest mass extinction event in human history, and actually can be directly traced to the rise of us, mammals, and how we came about, and why we are the way we are. So that's what I want to talk about. Specifically, not only what led up to the asteroid 65 million years ago, but the results of all of that. Mammals start rising up, and then finally the lack of CO2 causing monocots to start coming into play. By the way, we're actually on this map. I stopped this on purpose. Mammals are right here, right? Mammals start rising up right around there, right after the asteroid, but human beings specifically are right in that area right there of this last 100 million years. And again, an even smaller portion of the map before. So, four main ideas. What happened when the asteroid hit 66 million years ago? How did that asteroid hitting change the animals on Earth? How did it change plants on Earth? And how did we evolve as a result of those changes? How did plants evolve to appeal to us? So, first, what happened right before the asteroid hit? The big thing that happened was dinosaurs started eating grass. Believe it or not, that's a huge deal, that dinosaurs start eating grass. We know they start eating grass because we found it in petrified dinosaur poop. If you look in petrified dinosaur poop, you see this stuff, and that is, in fact, primitive grass blades. So we know that there were grass-eating things right before the asteroid hit, and that's going to be a lot more important in a second, but let's get to that asteroid. It's a meteorite, it's an asteroid, it's the largest mass extinction event in history. It's a meteorite known as Baptistema. And it hits the Earth at somewhere between July and August 65 million years ago, which is really specific, but we know that because when we look at this fossil evidence of when this asteroid hit, we see pollen from both water lilies as well as lotuses. And water lilies and lotuses are only open at the same time in July 65 million years ago. So there you go. The comet that hit is about as big as Mount Everest. Baptistena is about as big as Mount Everest, or roughly about the size of Manhattan Island. And let's first talk about it actually coming into the Earth's atmosphere. When it comes into the Earth's atmosphere, it leaves a cavitation bubble. And the best way to describe a cavitation bubble is with a bullet. Bullets travel very quickly, like asteroids or meteorites, and they leave cavitation bubbles too. That's what I'm showing you here in this ballistic shell. As this bullet cuts through this ballistic shell, it does so fast and with such force that it actually physically spreads out this gel. Now, a lot of people are tempted to say that there must be air inside there, but the reality is there is no air inside there. There is nothing inside there. And you can see that that's true because the ballistic shell actually closes up. I mean, there's air all around it. Why would air close in on itself? That cavitation bubble is a vacuum. It's nothing. It's space, literally space, like outer space. So if you were to look up at the sky about a second before Baptistena hits the world, what you would see is a dark little hole in the sky. You would see a night sky in day. It hits right in the Gulf of Mexico on the Yucatan Peninsula, right next to Florida and Texas and Cuba. And it hits with something like, not a million, but 1 billion times that of the atomic bomb, that of Hiroshima. So here's Hiroshima. Here's the hydrogen bomb, how much devastation the hydrogen bomb would have caused in Hiroshima. And then you multiply that by 1 million, and you get the force that Baptistena hit the Earth with. And when that happens, something very special happens. Baptistena burrows, literally vaporizing dirt as it goes about 7 miles into the earth. And as it hits Earth, because for every action there's an equal and opposite reaction, it throws up a column of what amounts to molten rock or gaseous rock into the atmosphere. So high into the atmosphere that actually, in fact, even leaves the atmosphere. Some of it can be seen on Mars today. Some of it hits the moon. But most of it actually, like this column of sand, falls back to Earth. And when it falls back to Earth, it begins to heat up the Earth's atmosphere. 17 billion tons of instantly gasified rock heats up all of the Earth's atmosphere to about 200 degrees Celsius, roughly about the temperature of a full-size commercial pizza oven on full blast when you stand right in front of it. And it does so overnight, killing virtually everything on land and most things in the water too. So dramatic were these tiny little superheated glass silica balls falling back to Earth that they actually kind of snowed. And this layer, 66 million years ago in the fossil record, can still be seen today. That's the evidence of those balls. Those tiny little 17 billion tons of rock falling back to Earth leave this layer in the fossil record that can still be seen. Below that, there are dinosaurs. Above that, there are no dinosaurs. And that's how we know that this asteroid killed those dinosaurs. So the question is, what survives? 200 degrees Celsius overnight, 1 million times that of the force of Hiroshima. What can possibly survive? Well, mammals. Why? They burrowed. Dirt's a really good insulator. You don't have to go too far below ground before you're fine. You're out of the heat of the asteroid. And in fact, this guy burrowed too. This guy burrowed too. You don't recognize him, but that's us. That's our most distant mammalian relative, what's called the primal placental mammal. That's what we looked like right after this asteroid hit. He was burrowed in a hole somewhere. Thank you, Grandpa, and he lives. Also, plants live. Monocots live because their growth centers are actually below the soil, so the heat of the meteorite doesn't kill them. Some dicots live, most of them die. Some dicots live, mostly because their seeds are in the ground. So, what dies? Well, everything else. All reptiles and virtually all insects. And this is a huge problem. This is a huge problem because now there's no insects to pollinate plants. But no worries, because we're going to actually get past that. Around this time, something else is happening. The Himalayas are starting to be built. And when the Himalayas are starting to be built, all the CO2 is being sucked out of the atmosphere. So dicots have a hard time, because they can't get enough CO2 to make their food. Monocots, though, with their growth centers below the ground, don't worry about the heat of the asteroid, and they have a secret weapon to accidentally counteract this lack of CO2 that's now into the air, thanks to the Himalayas being built, Mount Everest being built. They have these things called bundle cells, which literally suck CO2 out of the air actively, a lot like roots absorb nutrients from the ground actively. And if you're constantly sucking CO2 out of the air, you don't have to worry about there being less CO2 in the air, because it doesn't matter. It's just constantly being sucked in. And as a result, grasses and their bundle cells take over. Not only do dicots get taken out in large part from the fires and the meteorites, but they also can't regrow nearly as fast because of the lack of CO2 in the air. And monocots take over the place. But that doesn't matter because there's still no insects to pollinate it. But plants get around that. They look around and they realize that, yeah, there's no insects, but there's plenty of mammals. And without any dinosaurs, without any beetles, without any insects, they have to rely on those mammals to help pollinate them and spread their fruit. So if we look back in the fossil record, what we see is we see the first fruits that turn red when they ripen. color. That wasn't important before because a lot of insects can't see different colors, but we can. Mammals can. We like red things. Red fruit is attracted to us, and plants learn that, and they learn to turn color when they want us to eat them. They also protect their seeds with peels, which is great for us because we have hands that allow us to actually peel these fruits. Plants literally start evolving to us and actually determine even something a little bit more creepy, and probably my favorite thing. Remember, at this time, there are mostly grasses on Earth. Most of the world is a grassland. There's not that many dicots. What I'm showing you here is two pictures. These are called the Fungoli chimps. They're actually the most advanced evolutionarily chimp species in the world. They're our closest ape relative. And they live not in jungles, but grasslands, just like our ancestors lived. And something really funny happens when you startle a Fungoli chimp. If all of a sudden this group of chimps hears a sound, one of them does this. He stands up on two legs. Why? Well, he has to see over all this grass to see if something looks dangerous. In other words, all this grass being around, all these monocots, all these fruiting, flowering plants, actually directly cause our ancestors to stop walking on four legs and start walking on two. Next time you hear a loud noise and you perk up and look up, I want you to remember that that's not something that you did. That's something that your most distant ape relatives did 2 million years ago, because monocots happened to have bundle cells, and at that time the Himalayas were being built, and monocots were really good at surviving the fires from the asteroid. And that's what was covering the Earth. You can actually directly trace asteroid to monocots to us walking around on two legs, not four. So that's that. 66 million years ago, asteroid hits. Basically wipes out all life on Earth. Virtually all insects, virtually all reptiles, just really mammals surviving. And so plants, if they want to be pollinated, evolve to appeal to mammals. Their fruits change color, red. They get peels because we peel them. And it changes Earth as well. It locks away a lot of CO2 in the atmosphere, which causes monocots to actually start growing out of control. Monocots with their growth centers below ground so the heat of the asteroid doesn't affect them. And as a result, you get lots and lots of grasses, lots and lots of mammal apes roaming around those grasses eating fruit, and the Fungoli chimps having to stand up to see over those grasses, and eventually us. These apes that walk up on two legs instead of four. How curious, but it can be directly traced back to monocots and that asteroid 66 million years ago. So that's it. That's plant evolution. That's an explanation from how you go from the very, 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 very first plants in Scotland 500 million years ago, literally almost 250 million years before there were even dinosaurs on Earth, to us standing on two legs only 1 million years ago today. Thanks a lot. I hope you enjoyed it. The next chapter is all about plant growth and development, and I'll see you then.